Hey everybody, welcome back again here. I wanted to try and do something this time do a different series on here rather than just my normal machine learning videos. This time I want to see what would happen if we got more into a project rating system where, for example, you could work on just a side project and put it on GitHub, send that GitHub link to me in some way, and then you can then have your project featured on here where we can go through, rate it, and see mostly how reproducible could your project be. That's the main goal of this series, would be whether you're a scientist, engineer, whoever that might be. Everybody wants to do machine learning, but not everybody knows how to properly set up a machine learning project and make it reproducible and reliable regardless of who is working on it. So for example, I might make something that is very reproducible, but even then I might forget some things here and there just because I might be in a rush or might forget to do something. And so today, as a kind of first example, I want to actually work over a small side project that I did over the past week, just to show what this kind of setting, what this kind of series might look like. And maybe then we could even have some discourse in the comment section just to say maybe something I missed, or maybe something, if in this case, this project's going to be over autoencoders. So if there is somebody more knowledgeable about autoencoders than I am, they might be able to say something else that I might have done wrong, or something that I did right that maybe normally people do wrong, something like that. So that way we can all get on the same level of what can be reproducible for a project, what can you do to show your project off, because obviously at some point you're going to have to show that to a client, show that to a boss, show that in a research paper, something. So whatever, not only do you have to make your project reproducible, but you also have to show it properly as well. So in this case, as I mentioned, we're going to start with my project here that I just did quickly over the past week, just to throw something together. And in this case, I want to look at the latent space over the MNIST images. So if you're not familiar with what MNIST is, it is a general pictures of hand-drawn digits, and it is a decently large public data set that's used very, very often for benchmarking, image classification, machine learning projects or models. And so this particular background for this workbook came as inspiration from Nate Python's latent space example, which this here is a link online to go and see that. So what I'm going to try and do going over this video is essentially see what was good in the workbook for reproducibility, showing, setting up your model, etc., etc. What could be improved, and there are some things that I realize now that I actually did forget, and there were some things that I realized that I purposely left out. And so as I go through this workbook, I'll kind of grade it and say, okay, I should have done this, I should have done that. And in the end, after this video, I will actually go through, make all the changes that I mentioned to this, and I will put it on a GitHub repository, and that GitHub repository will be in the description if you would like to go and see that for yourself. So with that, let's get started rating this little project that I have. So first off, it's not too bad of an opening. Gives you, first cell here gives you a nice representation of what is to be expected. It's also very, very nice to say, hey, if you got inspiration from somewhere or if you got code from somewhere, both are perfectly fine. Just make sure whenever you do that, you are giving credit where it is due. That is something that, as anybody that's writing code has to do. Everybody that writes code is just going to go online, try and find something that has already been done and copy paste that into their code. But whenever you do that, you have to make sure that you actually credit that wherever you got it from for multiple reasons. One, because it's the ethical thing to do. And two, because if for some reason someone later on comes back and looks at your code, since you copy and pasted it, you probably are not going to remember it, and you're also probably not going to be able to explain it. So that link there will be able to tell somebody, hey, this is where I got the original idea from. There might be more information there to figure out why I got this and why it's written the way it is. So whenever you're writing anything, if you got inspiration or if you got copy and pasting it from somewhere, make sure that you always have that link. And whenever I'm writing any sort of code, whether it's from Stack Overflow that I might have copied from or a blog or whatever, I always want to make sure I put that link there. So in this case, this is the link to Nate Python's a little web page where he had an example that I try and recreate in this workbook. Something that this may or may not be beneficial, and this kind of goes towards having a general preference of how much writing do you want to have. Usually, you obviously don't want to have too little in the way of explanation, because then somebody might open this up and have no idea what this workbook is, other than the actual name of the workbook. But on the other hand, you don't want to write an actual book in this first cell. So in my mind, this is actually a decent enough of a first cell, but I'd be interested to see if anybody else has any other ways that they might think that would be better for this. Do you think that it should go over a brief summary of what the different sections are going to be and how they're formatted? Or do you think that you might want to do a little explanation of what an autoencoder is in this first cell, since I don't even mention what an autoencoder is or the fact that we're going to be using them here? So be interesting to see everybody else's thoughts on what actually would be best for this first cell. Now, as we're going along here, we can see we're setting up usually for your first cell, your first coding cell. That's the nice spot where you want to put all of your library functions imports. So that's good there. Then cells here, we're adding in the actual training data. So for Keras, we've loaded up this from Keras, the MNIST dataset, and then we're going through and just looking at the data. That's always good. When you're looking, especially if it's data that you've never seen before, it's very nice to just have a cell to print out your shapes of your training and test data set. And if you've noticed, that's something else to note, is that this is automatically split up into your train and test data set as well. So unlike in the other machine learning tutorial videos that I've done, I've mentioned how usually when you do your train test split, it's 90 and 10%, or if you're doing training, validation, and test, it's 70, 20, 10. In this case, they've done it for you, so that's good. And then just to give a little sample, we can see here in this cell that you have all of some sample images with their classes. So we can see this here is a 5, we have a 0. So nice way, it's always good to look over your data first before you actually start coding anything. So that's why a little bit of data exploration, and it might be good in this case to actually put a section here to say data exploration or something like that. For example, something like this. Even if you don't have any text in these section headers, it's still good to have them, because then what you can do, if I open up the side page here, on VS Code at least, when you're working with Jupyter Notebooks, you can see that we have a timeline and an outline to say when we edited something, and also similar to a PDF, you can go over and actually click on these and go to these different sections. So it's very nice to have these multiple sections, and you can see this first MNIST here, I have it with one pound sign, and so that creates a header 1. And then with these, I have the 2 pound signs, which creates a header 2, and it actually formats those properly. So that's another reason why you would want to have a header section. But then we actually get into here, it looks like the actual model coding. And something I did not see before this, maybe it's, I know I wrote this, but you would want to see something about setting a seed. So when we're doing machine learning, the one thing to remember is this is all very, very random. Every time I create this model and train it later on here, I'm going to get a different outcome. Even if I give it the same input, even if I run it at the same time of day, or whatever you want to say, you're going to get different output. So when you're doing projects like this, or benchmarking projects, or whatever you want to think for these, it's best to have a seed set somewhere at the top here. So maybe before even this, maybe even this import cell here, you'd want to set some sort of seed for, in this case, Keras and NumPy. That way, as we're going through here, we could run this whole entire notebook 50, 100 plus times, and it will always have the exact same output, no matter what computer we run it on, no matter when we run it, no matter how many times, it will always have the exact same output because you're setting a seed. So that's something else that should be noted, could be added to this notebook to make it just a little bit more user-friendly as well. And then we can see, it looks like we're getting out of the data exploration and into the first one here. We can see this function is the variational autoencoder. And we're creating those models, it looks like. So it might be nice to add your header here for variational autoencoder. And so here, I'm not going, for these type of notebooks, I'm not going to go too deep into the actual workings of the models or the architectures or anything like that. I'm just going to kind of brush over all of this. And then later on, if people want, I can make videos about these, such like variational autoencoders or autoencoders in general. But for right now, we can just understand that this cell creates a layer in Keras, a custom layer, and this one creates the actual encoder and decoder models. And then we actually have a custom model class that does a custom loss function. And something else to note here is we can see that this we have the pulled from. So again, going back to those links, we have the actual pulled from link. So this will take you to where all of this code came from, since that's the little tutorial on variational autoencoders from Keras.io that I found these at. However, since I had to make one change to this, I actually added a comment here. So that's something else good to know. As you're adding the codes, if you run into an error, say maybe the tutorial was made with an older version and something's changed in the version you're running of, say, Keras, NumPy, or whatever, so you need to change the code, it's nice to have that documentation in a comment to say why you changed the code. So here I had to add a call function, and I have that documented here. And while we're on documentation, we can see we have a little bit of it up here. This may or may not be self-explanatory to you, and this kind of goes back to, you want to have the right amount of documentation, similar to what I said before, but you don't want to put too much. So again, that fine line is general preference. In this case, for this first one here, there's some decent documentation. There's no comments, but it's small enough it doesn't really need any comments. Here, I added some comments to this, so like this is your encoder section, set up your latent layer and your encoder, and so on. And then something else that I added was that the latent space is 2 as we're going through for all these 2s here. But for example, I could also add a comment here to say, hey, not only is latent space 2, but it wasn't put in as a variable because in this version of Keras, if you say just make a latent space variable and place it in these values, it will fail because you're not setting that variable up in as a TensorFlow node, and so that will actually fail if it's just a normal variable. So I don't have something for that, but I could. So that's, again, going back to how much is enough for you. Again, you don't want to comment every single line like, oh, why this line exists, why this line exists. That's way too much. But at the same time, I could also see where somebody does say, yes, add something about why you don't have a latent space variable. Something like that would be very nice to have. And same with here. This is just a very large chunk of code. It might be nice to have a comment or two throughout here to say why these are set up the way they are. Or also what this actual class does. Alright, so then we go through in this next cell and we make the encoder and decoder. We print out the actual graph of the encoder and the decoder, which is nice. It is sometimes nice to see these summaries, simply because even if you're just documenting, it's very good to know, okay, what's your input, what's your output, and if you run into any errors later on down your workbook, you can work your way back up here and say, hey, did I mess up on one of these layers, or am I missing a layer, or whatever it might be. So this is always nice to have, and it's nice to, when you're, for documentation purposes, again, if you're writing a documentation for a company, or if you're putting this into a research paper, regardless of where it's going, you're most likely going to want to actually document what your model is, what your architecture is. So it's always nice to print these out regardless, because then you won't forget to do so later on. This tells you, hey, make sure you document it. So that's good to have. And then we make the variational autoencoder here, compile it. Okay, so this looks like we're actually going to setting up some processing here. So again, we do some pre-processing to the test and training data set, and then we start to fit. It looks like we fit for 30 epochs, we shuffle. All right. That runs through. Then we get our summary of the actual autoencoder itself. And now we're going through here and we're actually, looks like, looking at the output of this autoencoder. More specifically, in this case, we just did an example of what would happen if you just passed 2 random numbers for your z values and for your latent space into the decoder. In this case, it prints out a number 7. So we at least can see that that worked. It did train. And something else to note, again, you might want to have a section to say like, hey, training's done. So maybe have a markdown cell before this to say that yes, this is the actual section that's going through and working over the training, or working over the output of the variational autoencoder. And we go into another, looks like plotting cell here. So not bad. This is pretty good documentation. Something to note is that in VS Code, I do have an extension that then, if you put in these 3 double quotes, it will then auto-generate the rest of this. So it'll generate a, So it'll generate a summary. It will then generate all of your args, and then if you have an output, it will have a return section down here as well. So that is also something you might be interested in if you have that. So we go through and we can see, okay, that's very nice. That'd be a nice picture to put in PowerPoint or something to say, okay, you're going over your latent space. Here's what every number in that latent space looks like based off of the output of the decoder. Now here we can see we have a classifier section, so that's pretty good. That's pretty good. We have your create classifier model function. And something I will note here, because you'll see that we have functions instead of just throwing everything into a cell and clicking run. This is good practice to have in a Jupyter notebook, because say you want to actually turn this into some sort of pipeline where, oh, you want to train up your variational autoencoder, train your classifier, do all the pre-processing, and then form these plots and save them. And you just want to do that on the click of a button. Maybe you have to do that frequently for whatever project you're working on or whatever. It's nice to create these functions in Jupyter Notebook here and then have cells that just run those functions. That way you can just copy and paste the function, put it into a Python script, and then copy all of your function calls, put that in your main, and there you go. You have a decent pipeline. And then you just need to put a comment at the top of that Python script to say, hey, do not edit this, edit your Jupyter Notebook. And I know there are libraries out there in Python that can convert Jupyter Notebooks to Python scripts. I've had to work on libraries with those before. They're not very end user friendly. So I would say I would prefer to do it the hard way of just copying and pasting. That way you know you're actually doing it correctly. All right. And then we're going through here, and it looks like we're training the classifier, so that's not bad. That's not bad. We're going to predict. So this here we can see the same input. So we know that the image up there was 7. So we can see that the classifier predicts 7, which is good. So we have the link between the variational autoencoder and the classifier. All right. And now we're doing another latent space function here. Okay. So with this, we can finally start to pin everything together. It looks like at the bottom of this workbook, where you have each one of these colors is a different class. Now, I know that each one of these colors is a different class from the legend. It probably would be nice to have a legend header of some sort to say, hey, this is the classes, or a key header, or whatever you'd want to call it. Because if somebody else is looking at this, you may or may not be able to see that at first. It might, again, even though we're talking about MNIST, it still might not be completely understandable to look at first. But we can see all of the actual spaces where, in this case, we have the decoder take in that Z0 and Z1, create an image, and then send that into the classifier, and the classifier would classify that image as one of the integers. So we can see the different areas where those integers are trying to be made, at least. We can compare this with what we saw up here to, one, see if our classifier is correct, and two, to see if we actually got things working. We can see there is no 0, and 4 is a bit iffy for your 0 here and your 4 here. So maybe the variational autoencoder didn't really train on those rightly, or something else happened. So I think down here is the final piece where we actually go through and print out what each decoder looks like in that section. So that's here we have your Z0 and Z1, and then you have all of your integer class values here. Run them through, and we can see, yeah, the 0 didn't work out too well, and the 4 didn't work out too well. Everything else a little blurry. 6 and 9 and 1 and 7 did very well, it looks like. 8's a little bit blurry, but not a bad workbook. I would say the biggest thing would just be maybe a bit more documentation in terms of some comments here or there in these big. If you're going to have very large chunks of code like this, you should have at least 1 or 2 comments to say what some things are, or at least some breaks. Like right here, you do not want to have this right next to this. You want to have a space here just to make it more readable. And then for the actual setup, you should set up a seed so that way we get this exact same result every single time. Another thing, documentation wise, you want to set up your library versions preferably up in the top here around your section up here. Maybe, for example, you could put comments here to say what each version of, say, Keras, TensorFlow, and NumPy you were working with, and maybe even Matplotlib. Or you could, in this first cell up here, do a list like this, and then type in NumPy, then its version, and so on. So because there's no versionings, because there's no legend, that would take a few hits on this. And then again, there were not very many sections. We can see I added 2 more. There could probably be another 2 sections made. So, and each of those sections could have some documentation in them as well, and not just have the headers. Overall, though, the workbook is, for myself at least, just because I wrote it, easy to be followed. Somebody else might think differently. You're starting with your data setup, which is good. You set up the variational autoencoder, then you set up your classifier, and then you bring them both together at the very end. So it kind of wraps it up nicely like a little story. And then I can see this image and this image being put into a PowerPoint or a paper of some sort. So that's good. That is good. Overall, I would say I'd give this like a 6.5, simply because of the least amount of documentation. The way that I write documentation is, I think, okay, if I stop working on this right now and then come back to this in 5-10 months, am I going to be able to look through this and understand what is going on? This, I would say no, honestly, because I don't know why I would have this. I have the pulled from here. I know I have a very, very poor memory, and I know I have a poor memory, so I know why, or I know that for certain I would forget all this. So me personally, I would want to add more documentation, a lot more, in fact. But the overall flow is good. There's not too bad for the actual cells themselves. They are very short, which is good. Short cells, and then so you can do a lot of iteration and a lot of changing. The one thing I did see as well is accuracy was commented out. It's good that accuracy was commented out because you don't want to use accuracy. So that would have actually been another kind of deduction if you used accuracy. But at the same time, it would be nice to have a different metric used. In this case, since we're using softmax with categorical cross entropy, it probably would be good to use something like an F1 score since you're working with multiple classes. But I do know in Keras, at least at the time of me recording this, that I know of, you have to make a custom F1 score function. It's not one, you can't have like F1 here for that. Another thing you could do is you could have it print out precision and recall and then calculate F1 that way. But overall, not too bad. Like I said, 6.5. And that may or may not be for me being more harsh on myself. I don't know. Everybody else in the comments, you can tell me what I may or may not have missed, what should be added, you think. And with that, I will leave it here. If you have a project that you would like to have reviewed on this channel and to see where does your notebook fall? Again, make sure it is a Jupyter notebook that has been run like this, so that way I don't have to run it, because a lot of times you might be running with different versions of all of these tools than what I have, or different tools altogether. So if you have the notebook ran already, that would be very nice. And I think that is it. As I mentioned, this notebook will be in the GitHub repository, linked in the description below. And with that, I think we will leave it here for this episode. Thank you all very much for watching. If you liked this and would like to see more of these, feel free to leave a like on the video and subscribe for future. I will say I would like to also do a few of these as well, because it's been a while since I've done just these small few day to week projects. So it's nice to get back to doing something like this occasionally if we don't get any submissions. So I might do another one or two of these here in the future. But with that, thank you all for watching, and I hope you have a good day.